day, everyone. Wherever you are watching from, you are welcome to Brainball's Learning Consult platform. I'm your regular host, Mr. Amaro. Today we'll be talking about conjugate of binomial sorts. In our previous class we talked about rationalization of sorts. So when it comes to division of sorts, one thing we all have to note that we need to know the difference between the conjugate of binomial sorts and rationalization of a single sort. Now, when your denominator of the sort is a single sort, for instance, when you have something like this, is a single sort, you just rationalize. I've explained that previously, so do check out that video. Rationalize. This is much easier than the conjugate of binomial sort. Now, the idea is this: when your sort is in binomial form, meaning your sort is having the denominator of two different terms or two different values. For instance, maybe we talked about root 2 plus root 4, or no, let's say root 3. You can see that our sort is no longer monomial, it's now binomial. And because it is binomial, it's having two terms, we have to take what is called the conjugate. And the idea of the conjugate is very important, especially when it comes to difference of square. And in difference of square, for the conjugate of binomial sort, difference of square roots is important. In fact, you have to know this. Back to your elementary quadratic equation, or back to your elementary quadratic expression, where you do the difference of square or the difference of square roots of an expression, such as this. For instance, root a squared minus b squared. You'll be told to factorize this, which is pretty easy. Of course, you will know that is a plus b, open bracket, a minus b. This is just a typical example of what we will do here. So you just follow the following examples. Example number 1, 5 plus root 3. So that will bring us to conjugate of binomial sort. Now, the conjugate of binomial sort is actually the opposite of that particular sort. And what it means to be the opposite is just the changing of the sign. Now, I will give you this example. For instance, a plus b. The conjugate of a plus b is actually a minus b. So, if you have a minus b, taking the conjugate is actually a plus b. So, the opposite is that sign. So, the opposites are going to multiply themselves. The opposite are going to multiply themselves. So, for instance, if we have this as our denominator, we're going to take the conjugate, which is a minus, right? You already know that this is a difference of square. Oh, that will be a squared minus b squared. I will explain now. So let's multiply out. We'll arrive at this. A times a will give us a squared. That will be ab plus ab minus what? B squared. This cancel this. You are having a squared minus what? B squared. So that brings us to this notion that the opposite of a binomial, a conjugal binomial is what, or a conjugate binomial, is this changing of the sign. So in conjugate binomial of the sort, what we do is that we'll use the opposite of that binomial expression to multiply itself, thereby cancelling out. Your final expression will be what? The difference of what? Square.